Hello, in this video we're going to start with example 3. Brian said that the piecewise function graphed on the right has a domain of all real numbers. State 2 reasons why Brian is incorrect. Okay, so we know he's incorrect. I'm going to first just illustrate we're talking about the domain, and we have to remember that that means our x values. Okay, and we know that he's incorrect, so our x values are going right to left. How far or where is the graph going to go right to left? So I see this arrow here. That tells me that this is going to go on forever. So we could say negative infinity for this side. But as we continue this way, you should see here that we have a spot where we have 2 open circles. So this is 1, 2, 3. Okay, so this is the x value of 3, and there is no value for x defined there. Okay, so that is one of our reasons, because if it's all real numbers, we would need it to go from negative infinity all the way to infinity. It would have to be every number. So because there is no value for x equals 3, both circles are open. Okay, I'm just typing to make it go a little bit faster, but feel free to pause the video here if you're writing that down. Okay, the second reason is because if we would need this domain here to continue all the way to positive, actually that already broke us up. I'm going to give up on that part. We didn't have it there, but if there was an arrow on the end here, then we could say it's going all the way to infinity, but it's not. Okay, there's a closed circle. It actually stops here at 4. So that is our second reason. Also, there are no values after x equals 4. Okay, and again, feel free to pause the video, but I'm going to move on to the next question. All right, numbers 4 and 5 are similar, and this is where we're going to talk about those sets of numbers that I introduced earlier. 4, the function g of m represents the amount of gasoline consumed by a car traveling m miles. An appropriate domain for this function would be. All right, and here is we see this word domain. A lot of times I say x values. I guess here would be a good time to just consider it the inputs, because remember, we don't always use the variable x. In this case, it's actually not an x, it's an m, because it's m miles, and then g of m is our function. Instead of y equals, we would say g of m. Okay, so we're thinking about those inputs, the number of miles. All right, miles. So which of these sets could represent the number of miles? Okay, well, first what I would start with is that integers and rational numbers both have negatives. And then you'll notice here both choices say non-negative. Well, if something is not negative, it must be positive, right? So we can automatically cross out 1 and 2 because you can't travel a negative number of miles. Okay. We also know that integers are whole numbers, and in this case, you can drive like 3.2 miles or 4.5 miles. So that's why we have to go with answer 4, non-negative rational numbers, because you can have a half a mile or a 0.2 of a mile. So we have to include those decimals. Number 5, a store manager is trying to determine if they should continue to sell a particular brand of nails. To model their profit, they use the function P of n, where n is the number of boxes of nails sold in a day. A reasonable domain for this function would be. All right, and we have our sets of numbers again. So We are looking at domain again, so we're talking about our inputs, and we have to think about it's the number of boxes of nails. Okay, you can't sell a negative number of boxes of nails. All right, so basically that eliminates these three choices because they all include negative numbers. All right, we're going to go with non-negative integers. And I mean, if it had non-negative rational numbers in this choice, we wouldn't choose that because if you're talking about the number of boxes, it has to be a whole number, right? You can't sell 0.5 boxes of nails. Like, I don't think they're going to cut it in half. So they didn't give you that as a choice, but it was a choice up here. So you might see something like that. So with these types, you just have to think through the situation and ask yourself what types of numbers make sense for that scenario.